Hello there and welcome. In the previous episode, we created this demo project and we connected it to our server. We also used the endpoint that we have to send a JSON with some saved data and also fetch this data back into our game and update the high score. But I told you that this is not enough if we want to have multiple users, because at this point we only have one JSON that is always getting overridden. So we need to create a JSON for each user. So each device will generate its own JSON and save its own data. And this way we can have separate files for separate users. So before we do some changes in our API client script, we're going to connect to our machine. And at this point, the file that we are using for this endpoint, we can do ls and cd. Our service is using this simple endpoint, but this simple endpoint only works with one JSON. And if you know a bit about Python, you can clearly see it. So let's just cat it. As we see, we can use these endpoints. We can save a JSON using this endpoint over here, and it will simply go into this path and it will create a JSON using this save JSON method, which is this one over here. And it basically checks if there's a file there, and if there isn't or there is, it will simply take all the data from the JSON that we provided and it will create this JSON. So it will always override this one file, and it doesn't matter from which computer or from which user. It doesn't care because we are not providing any kind of information. All we do is make an API call to this method and to this method. But as you can see, there are no parameters. And if you know a bit about API calls, we usually send parameters to customize our calls. And in this case, we don't have any parameters. We simply call this endpoint. So in order to change the way it works, in order to actually send a parameter, we need to change the entire script. Now we have several options. We can either simply edit this file and replace the entire script, and then all we need to do is save the file and maybe reload the service and everything will start working. This is the very fast and simple way. But if you want to test your new script and the new functionality and you still don't want to hurt or remove the old one, you should create a new file with the new functionality, with the new script, and only when you see that everything is done, only then you're going to delete the old one. Because think about it, think about a situation that you're actually in production, you have some kind of service that is using this script, and you have users that use your application, and then you decide to make a change. You're not going to change your actual production file, right? You are going to create some kind of test file that you're going to test, and only when all these tests are complete and you see that everything is working, you are going to make the change and you're going to stop using this old script and using the new script. So we are not going to replace the code inside of this file. We are going to create a new file with the new script and we're going to simply change it, okay? So we're going to keep the old file as a backup. So in the description of this video, I'm going to provide you the new script, okay? This will be simple endpoint v2. It's very similar, but it's a bit longer. We also have the same endpoints over here. We can see set data, get data, and we also have the help one. But the change that we made is that in those API requests, API endpoints, we also added these arguments, these parameters, player ID. So we can basically pass a parameter into this call, which is the player ID, and then we can use this player ID inside of the method. So even if you don't know Python, it's very similar to C#. We basically have a new variable, a new parameter, player ID, and we can use it and pass it into the load JSON or save JSON. And then inside the save JSON, we basically get the data, but we also get the player ID. So we can basically create a new file named as the player ID.json. So now instead of having one file named data.json that will always be overwritten, we're going to have a folder, a directory that will contain a lot of different JSONs. And each time a new user or a new device is trying to save data, it's going to generate a new JSON file named as the player ID, and then it will simply save this file into this folder. So now if you have many users using different devices, then each user will have its own JSON file. And this way, when we also want to load the JSON, we're going to provide the player ID that we want to load, and we'll simply look for this file, this JSON that belongs to this specific device, and it will load the data. And this way, it's not going to override the other players. If we have the same player saving the data again, then yes, it's going to override the previous data, but it will only be for this specific user. And this is the functionality that we want to get. Again, we have two ways to do it. We can either create a file manually and simply copy paste this code, or we can use SCP like I showed you. We can open the terminal and Windows and copy this file into our machine. We are not going to do this. We're going to do it the lazy way. We're simply going to do nano. We're going to give it a new name, simple endpoint v2 py for Python. And now we're going to take our endpoint. We're going to copy this entire code. And we're going to paste it inside, okay? So now we want to save it. And previously I showed you several ways we can save a file, but the simplest way is to actually press on Control X. So it's like we want to exit the editor, but then it will also ask us if we want to save the changes. So we press on Y and then enter, and it's done. So you don't need to do what we did before, Control O and then enter, and then this is much simpler. You simply do Control X, Y, and then enter. So now this new script was saved, and if we do ls again, we can see this file over here. Now, if you're wondering why this one is green and this one is white, that's just because we made this one into an executable in order for the service to use it. And this one is still not an executable. This is just a script that was still not used. Now again, in order for our service to actually use the new file instead of the old file, we need to change the name of the file inside of the service, because these are the scripts that we use. These are the endpoints, right? It has this code inside, but the service is a separate file that is using this file and executes it, okay? So before we actually change the file inside the service, we also want to make this one into an executable. So for this, we use sudo -x, or actually +x, because we want to add the executable permission. If we do -x, then it's going to remove the execution, but we want to add execution, so +x, and then the name of the file, we can autocomplete, but this time we're going to use v2 v2.py. We're going to press on enter. Oh yes, my bad. It's not +x, it's actually sh mode, so we need to change the mode. Okay, I forgot this command over here. So sudo change mode +x, and we're going to press on enter. And now if we do ls, we can see that both of these files are green, and it means that they're executable. So now that both of them are executable, we want to change our service to use the new file instead of the older file. And we can do this by simply editing our service file. So we can do nano and we need to find the service file, and all the service files are located in one specific folder, so we can simply reference this folder using this absolute path. So etc system d and then system and then the name of the unit file, so simple endpoint service. And again, you can also create another service file, a new one that will use the new script. So instead of editing the old one, you can simply create another one and execute the new one and then stop the older service, okay? But we don't need this because we're only going to have one service. We simply want to change between the files, so we wanted to use this one instead of this one. So now we're going to edit, and the only change that we need to do is to change the name of the file that it's using, because this is basically the file, the Python script that the service is using. And in our case, it's using the old one, so we wanted to use the new one. So we're going to simply change the name to v2, okay? And now we're going to save. So again, Control X and Y and enter. But we're going to get an error. You can see this error writing permission denied, because we cannot edit and save service files unless we are the root. And the root is like the admin of the system. It's like the manager of the system. We are connected as a user. We're connected as our specific AWS user. So we cannot edit this file because this file is not giving us these permissions. So now we have to exit this editor. So we're going to do again Control X, but this time we're not going to save because we are not allowed to save. So in order to exit, we simply say no, N. And now we exited without editing it. So in order to edit this service file, we need to either create a new service file or we need to give ourselves permissions to edit this file. Now we can solve this very, very easily. All we need to do is use the same command, but before the nano, we simply add sudo. Because we simply say we want to use the root permission. We are doing this command as the manager, as the root, okay? And if we do this, it will allow us to edit the file and to save it, and we're done with it and everything is working, okay? But I also want you to learn a bit about Linux, and we're going to understand how to actually change permissions for files. Now again, you don't have to, you can just use sudo nano and that's it. But in order to actually give ourselves permissions, instead of trying to edit this file, we do this command ls-l and the file name, and again it needs to be the full path because we are not inside of the same folder, and we press on enter, we can see this line of information. And it basically tells us the different permissions this file has. So we can create a group that will be the owner of this file and that will get special permissions. And then we're going to make our user a part of this group. And all the permissions that the group has, the user will have. So it's very beneficial, especially inside of a company. Imagine you have the development team. So you have a team of developers. You want to give your developers permissions to edit the different files. But maybe you have another group, maybe some kind of maintenance group that should not edit the files. They should have access to your system, but you don't want to allow them to edit your files. So you're going to create a group named maintenance and you're not going to give them writing permissions, okay? So we're simply going to create a group named developers and we're going to add our user into this group. And we're going to make this group the owner of this file and we're going to give it writing permissions, and then we're going to be able to edit and save this file. Again, all of this is not relevant because you can simply do sudo nano and edit this file as the root, okay? So in order to create a group, we're simply going to do sudo, and another thing, only the root, only the sudo has permissions to create groups and to assign users into groups, okay? So we still need to use the sudo permissions. So sudo, and we're going to create a group by using this command, group add, and we're going to give a name to the group, developers, okay? So now we created this group and we want to add our user into this group. To do this, we simply say sudo user mod, so simply modify the user, and then -ag, so add to group or append to group. Which group? Developers. So to the developers group, and which user? EC2 user, which is our user. So now our user was added into the developers group. But at this point, our developers group still doesn't have ownership over this file because we saw that the root only has permissions. So now we're going to give our group permissions over this file. So to do this, we say sudo chown, so change ownership, root, and developers. So this is the previous owner of this file, and now we're going to change it to this group, okay? And we need to give the name of the file, so we need the full file. And we press on enter. And now if we do this command, ls-l, we can see that the developers group is the group that is owning this file. The root user is still the owner, but the group that has permissions is the developers group. Now this won't help us because the group still doesn't have writing permissions. It only has reading permissions. So for this, we need to add writing permissions to the group. And to do this, we simply use this command, sudo chmod, which is used to change the permissions. And we use this code 664. And then we need to input the file name. Now, what 664 means, it's basically a way to represent the distribution of permissions. So I'm going to show you on the screen the logic behind of it. So now we're going to press on enter. And if we do ls-l again, we can see that the permissions were changed. So the owner, which is root, still has reading and writing permissions. But the group, which is developers, now also has writing permissions. And before, it didn't have writing permissions. And because our user, EC2 user, is a part of the developers team or developers group, it will have also reading and writing permissions. So of course there's more to it. We can also add executable permissions and we can do other things, but this is the basics. So you actually learned about permissions. So this was a bit of extra knowledge, but now you also learn about this. And again, you can simply use sudo nano and edit the file as the root, but now you don't need to do this. You can simply edit this as the user. Now, at this point, you will still not be able to edit the file as the user because the user still need to be refreshed into the group. So it's still not a part of the group. And if we do groups and the name of our user, and we can see that it is a part of the developers group, but sometimes we need to exit, we need to relog in, and only when we relog into our machine as this user, it will be a part of the group and it will get the permissions of the group. Okay, so we're going to disconnect and we're going to connect again. And now we can still use the older commands so it remembers the commands. So we're going to do nano, again, as a user and not as a root. And let's go over here and modify the file. And now we do Control X, yes to save, enter, and you can see that it worked. And as a user, we managed to edit and save the file. So all of this could have been avoided if we just used sudo, but now you know how to change permissions. And we can also do cat, or let's just do this and do cat just to make sure that the file was actually modified. And yes, we can see that the file was modified. Again, this is the full path of my file. If you change the location of the file to another folder, or maybe you change the entire folder name that contains this file, you should also change this. But again, this should not change unless you change the names of the file. We have our Unity server folder, and inside we have this simple endpoint v2 folder, okay? So now the service file was updated, but in order for the service to actually start using the file, and so we can actually use this endpoint, we need to refresh the service. So sudo systemctl daemon reload. And now we need to restart our service, sudo systemctl restart and the name of the service. So we don't need to provide the full path. We only need to provide the unit file, the actual file, and enter. And now we need to basically check if it's running. Status. And we can see that the service is active. We can also see the different logs. So let's quit. And now when we try to connect to this endpoint, we are going to be able to reach the different get data or set data as before. Now, we can also confirm this by simply opening our browser and inputting the new data. But it's not going to work because we still need to provide a player ID, and in the browser, we don't have a player ID, right? We don't have this information. We can only get it from our game. So the changes that we're going to make are inside the Unity project. We're going to open our API client script, and over here, remember that we need to update the public IP because this is the old one. And if you closed your instance, if you stopped it, then the IP was changed. So we need to take the new public IP and we need to paste it over here. And now we need to add these parameters, this one parameter, the player ID. And the way we do this is by simply adding it to the URL. And because we're going to use it both for the saving and for the loading, we're going to add it to these endpoints. So the way we add a parameter is by using a question mark and then the name of the parameter, this equal sign, and what comes next will be the actual player ID. So we do the same thing for the get data, and this will be a part of our endpoint. Now, if in the future you want to add more parameters, you can simply add them over here. And of course, inside of this thing, you will have to do something like this and add the value. So it will be a part of the string, but obviously this will happen inside of the code and not as a string over here. So at this point, we only have one parameter, so we're going to leave it this way. Now in the saving, it's pretty simple. So this is the base URL, this is the endpoint, and we need to simply add the player ID. And we can do this by reference this save data dot player ID. In the loading, it will be a bit different because if we go to our loading method, we don't have a save data over here. This callback is of type save data, but it's not providing us the save data, right? Because we want to load the information, so we still don't have any kind of player data. So we will have to pass the player ID as another parameter into this method. And we're going to do this by simply adding another parameter, and we're going to say string player ID, and we're going to add it at the end of this endpoint, okay? The same way we did with the save. But now we also need to adjust all the other methods because right now we need this player ID. So we're using this. Let's do right click, find all references over here. So over here, we also need to provide the player ID. So period and ID, player ID. And we need to provide it in this method as well. So string player ID. And we also need to actually pass it through when we use this. So find all references, and we use it twice. We use it inside the awake, and we also use it inside the end game. So in both cases, we need to add the ID, but where do we get this ID at this point? We can simply use this get player ID method that will generate the unique ID. And remember, it's not a random ID. It will always create the same ID if we are on the same device. So we're going to use this get player ID method, and we're going to pass it inside as the ID. Of course, you can do something like this, string ID, and then simply get the ID from this method and then pass in the ID, okay? But to save space, we can simply pass the entire method inside and it will return the string. And the same thing we can do over here because we also need to pass the ID. And now we are passing the player ID inside, and inside we're passing it again. So we also pass the callback and we also pass the player ID. And then inside it receives both the callback and the player ID, and then we send the player ID to our endpoint. And this is the only change that we actually need to do because the Python file will do all the rest. Now, if we go to our server, we can see, let's do ls and then go inside this folder, actually, and ls again, and let's move it up a bit. We can see that all we have inside this folder is the simple endpoint 1 and 2. And of course, this is the one that we're using. So we can delete this one if we don't need it anymore because our service is using this one. But we don't have any JSON, right? Because we deleted the previous JSON. We also don't have this all player data folder inside, right? And that's just because we still did not use this script to generate our first JSON. When we are going to save the first JSON, it will check if this folder exists, and if it doesn't exist, it will create it. Create the directory if it doesn't exist, okay? So the first time we run this, it will create this directory inside this folder over here. So now we're going to run the game for the first time after we did these changes. And remember, the first time it's going to fail loading because we're not going to have a JSON file. But when we save it for the first time, it's going to save a first file and it's going to create a folder. So let's start. So now it failed to get a file, and that's fine. That's what we expect because it has no file. We're going to start the game. We're going to let the counter go down. We can try to get some kind of high score. Say 30. And now it was saved successfully. If I am correct, it was 46, right? Something like that. So now it was saved in the server using this device ID, this player ID. So now if we go over here, we can also open the logs for the service and see that the endpoint was actually used, but we can also do ls again, and we can see this folder created. And if we go into this folder, so cd and the name of the folder, and then we do ls, we can see that we have this JSON inside. And if you're wondering why it's so long, what is this name? This is the player ID. So this is the player ID of my machine. Now, I don't know if this is too secure to show you this ID. I don't know if you can actually do something with this, but I don't care. I trust you. But this is the actual player ID or device ID for my device, okay? So if I'm going to run this game on my cell phone, it will get another ID. And if we try to print the content of this file, we can simply do cat, and then we don't need to give the full name. We can just start with something and then press tab and it will autocomplete, press enter, and we can see the content of this JSON file. So we have the player ID, which is also the name of the file, and we have the high score 46. So now if we run the game, we can see that it loaded the score from the server and we see it over here. So now if we start playing and we beat the high score, it's going to override it. Otherwise, it's going to stay the same. But we can see that all of this functionality is working. Now, although this may be a solution for a small or a medium project, this is not really something we want to do for a big project. We don't want to create a file for each user. We don't want to have thousands or millions of JSON files, right? Because this is not scalable. Imagine we want to back up these files, then we need to copy all of them. Imagine just if we want to create some kind of API call to get a list of all the users for some kind of leaderboards screen, right? We will have to actually get all of these files or go through all of these files. So this is not an efficient way, and this is not how we actually store data on a server. I showed you how to do this because I wanted to do it step by step to understand how everything is working. But what we actually want to have is a database. And this database will allow us to save data and to load data exactly like we did with these files. But instead of having separate files for each user, we're going to have one database that will be even easier to back up if we need to and to do other things. So this is how usually production servers are operating using a database, okay? If you want to have specific use cases, you can save JSON files, but this is usually used for configurations and things like that. The real data, especially when we're talking about big amounts of data, we need to have a database. So later in the series, we are going to create a database on our server, and this is how we are going to save all of this data. So that's all for now. Thank you for watching. Please subscribe if you're still not a subscriber. You can also leave a like, and I'll see you next time.